Hi everyone, for today we're going to continue working with adding probabilities, but specifically we're going to look at these two-way frequency tables and how we can find probabilities from these. So what I would like you guys to do, if you could just please pause this video, I want you to try to look at this table and try to fill out part A for me. Okay, so let's take a look at part A. If I want to see the number of males that there are, I'm going to look at my table and look for where it says males, and I'm going to go down on that table. The total number is 30. If I want to see females, that would be 22. If I want to see the number of students going to college, that would be 29. The number of students not going to college would be 23. Now, if you want to find an overlap here or an end, the number of students that are male and going to college, I'm going to look at male and going to college, and the area that both they are male and they are going to college, where they overlap is our answer. So that would be 16. Female and college, I'm going to do the same thing. I'm going to look for female, I'm going to look for going to college, and there are 13. Now, if you're looking for female or going to college, this goes back to what we did yesterday. So we need to use our formula. I could add the two of them, but I need to make sure that I'm subtracting the overlap. So if I add how many females there are and how many are going to college, so that's where I'm getting this 22 and the 29, I can't just add them because I'm counting these certain students twice. So I need to subtract the 13 students that they share to get that there are 38 total that are female or college. So remember, this is our formula that we did yesterday, that you need to subtract the overlap so that you know exactly that you're not counting those people twice. So let's look at B and C. For B, it's asking what the probability that a person picked at random would be a female who is going to college. So this is really asking for female and college. So probability of female and college. And when I'm doing this is a little different than the above ones, because the above was just asking for how many people. This is asking for the probability. So if I want to do female and college, I'm going to take this female and college, which is 13. But when I'm doing a probability, I need to divide by how many total. So there were 52 total. So that is our probability of female and college. Now you could keep it as a fraction, or we could change it to a decimal, 0.25. What is the probability that a person picked at random would be a female or someone to go to college? Again, they're asking now for a probability. When I'm finding a probability, I need to divide by the total number of people. So I'm going to do probability of female or college. And for this, I'm going to use really this number. There are 38 students in there. I don't need to calculate that again. I already know how many students are fall in that scenario. And I'm going to divide by the total, which is 52, and that's equal to 2.73. Again, you could leave it as a fraction or decimal. So the major difference just in parts A and then B and C, this was the notation to ask how many. So what is the number of males? What is the number of females? And this B and C, we're asking for the probability of this happening. So when I'm finding a probability, I'm just dividing by the total. And in our two-way frequency table, our total is this bottom corner number. All right, one more question on this one. Explain why the probability of female or going to college, so that's C here, female or going to college, is not equal to the same as taking female and adding it to the probability of college. So I just kind of wrote it out with the probabilities of what they're talking about. This is the probability of female or college. This is the probability of female. And why can I not take that and add it to the probability of college to get this or? And again, this is going back to yesterday's lesson. There is an area that they share. So I can't just add the two probabilities. I need to actually subtract the area that they share. So you need to subtract the overlap. And if you see on this part to the right, I actually subtracted that 13 over 52 and I get the correct probability then. So this formula, and when we originally talked about it, I'm just going to add a page here so that we can kind of talk about this. This formula works two ways, and that's why we had those two formulas on that first day that we did this. I could take the probability of an event A or B, and to get that I take the probability of A, add it to the probability of B, and subtract probability of A and B. But I could also do it when it's not a probability. I could do it with just the number of people in an element or in a set. So the number of people in A or B is equal to the number of people in A plus the number of people in B, and I could subtract the number of people of A and B. Oops, sorry. This should be number. So that's why there's two formulas technically, but it's the same thing. If you just know that the OR is equal to the first plus the second, and you subtract your end. So this is our big formula. We're going to continue to use it today. We're going to look at one more question, and then there are some practice questions for you guys to do. So let's take a look at exercise 2. Exercise 2 is another two-way frequency table that is looking at males and females and whether they're sophomores, juniors, or seniors. Now, in this two-way frequency table, there are some missing cells. So you do have to go through before you could figure out the probabilities of any of these. You need to know your grand total. For instance, if I'm looking at the probability of choosing a male, well, I do know that there's 103 males, but I don't know what my grand total is. So I need to start filling this in. So if you look, I'm going to just look first at this total column. I have everything except the last one. So if I just add them going down, I would get 215. If I look at sophomores, I'm missing my females. That if it has to be a total of 70, then there are 24 females, which then I could total my whole female column and I get 112 females. On males, I know that juniors is missing, but this needs to total 103. So if I add the sophomores and seniors and I subtract for 103, I would get that there are 45 juniors. So that's how I fill in any missing cells. And you always want to have all of your cells, especially your totals. Sometimes these two total columns will not be there, and then you just need to kind of go through every row and add them up. One thing I like to do, especially when there are missing cells, I like at the end just add up going this way and make sure you get 215, and add up your totals going this way and make sure you get 215. It's just a nice little check to make sure that you did do it correctly. Okay, let's take a look at some of these questions. So if one student is randomly selected, find the probability of choosing a male. So in my table, I'm going to look at males. There are 103 males total. But I want to find the probability of that, so I'm going to divide by my grand total of 215. Again, you could leave them as a fraction. If you make them a decimal, they just might be not a nice decimal, so we could leave them as fractions. So if I'm looking for choosing a senior, I'm going to look at my column of seniors. And for seniors, my total is 47 over that 215. Choosing a female junior. So now I have two scenarios that are going on. So this is really female and junior. I'm going to look, here's juniors, here's females. There are 53 over that 215. So A, B, and C are basic probabilities looking at either one of the totals, or if they're giving you two scenarios, looking at the overlap. Now, D and E are a little bit different. Choosing a female or a senior. As soon as you see this or, you should be thinking of that formula that we did yesterday and then I just kind of went over today. So to get the or, I need to do the first scenario, so female, plus the second scenario, and I need to subtract their overlap, so that end. So if I'm looking at this and I'm calculating female or a senior. My females is 112 over 215. I could add it, and again, just looking at my table, my seniors is 47 over that 215, and I need to subtract the number of students that are in both. So female or a senior. Again, I'm looking at this table. Here's females, here's seniors. So this is the number that I'm going to use. So I'm going to subtract that 35 over 215. And I get an answer of 124 over 215. Now, if you want, because I did say that there were these two formulas, I could do this with a probability, or I could do it with the number of people in that category. If you just wanted to take this and you wanted to add the 112, the 47, and subtract the 35, I would still get this 124, but remember we're finding a probability, so I need to divide by that total of the 215. But if you don't want to type in all of these fractions into your calculator, you don't have to, and you could just do those top numbers if you would like. Okay, last one, E, choosing a junior or a senior. Again, if I'm doing an or, I need to remember that the or is equal to the females. Sorry, not doing females. Or is equal to, what am I finding here? Junior plus the senior, and I need to subtract that end or the overlap. So in this case, my juniors, if I look at the table above, I get 98, and I'm going to divide that by the total 215. Again, looking at how many seniors, there are 47 seniors, and I'm dividing that by the 215. And if I look at my table, there are no category, there's no box to look at that has juniors and seniors, because juniors is here, seniors is here. There is no overlap here. So I'm really not subtracting anything in this case because there are no students that are a junior and a senior. So I don't need to really worry about this because there's nothing to subtract there. There's no overlap. So when I add these, I'm going to get 145 over 215. I'll just add that up here. 145 over the 215. So lastly, I just want to kind of talk about that last scenario a little bit. If I have these two categories, junior and a senior, there's no overlap. So these are two events that do not share anything in common. So we call these mutually exclusive events. So if I have mutually exclusive events, such as being a junior and being a senior, there are no juniors that are also a senior, so there is no overlap. If I do have mutually exclusive events, this is the one and only case where you can add the two probabilities, probability of A plus probability of B, and you don't have to subtract anything because there is no overlap to subtract. So what I would like you guys to do now, there are a few practice questions. So I want you to try the practice questions, and the answer key will be posted for you guys to check. Have a good one. Bye.